Alright, so we got another complete the square problem here. This one looks like it's going to work out terribly because we have the number 49 with a leading coefficient of 4. So similar to what we just talked about, if we want to get into the form of just 1x plus something squared equals something, we know that we got to get rid of that leading coefficient of 4, so we're going to start by dividing everything by 4. So divide by 4 gets me x squared. 28 divided by 4 is 7. That's going to be nice and fun to work with. 49 divided by 4. Don't ever try to do math that you don't need to do. We don't know if we're actually going to need to do that division yet. We might as well just write it as an improper. So now, do you want me to keep, like, just telling us what we do, or do you want me to, like, play the whole teacher game of, like, ask you what we should do next?
I think next we would divide 7 by 2.
Yeah.
This would be 3.5 or 7 times.
Absolutely. So the first thing I do is I just ignore that for a moment, because honestly, it's too much in my brain. The other way we can do that is move it to the other side. And that's how we just, like, ignore it or get rid of it. But I don't like, that's an extra step that I may not need to do. So I agree with what you said. We take the b and divide it by 2, but don't do 3.5. Do the improper fraction, right? So we think about, so if, right, we're going to play the big if game, and I'm going to go ahead and just jump my gap and come down here. If this was 7/2, then this will work out to get the b value of 7. So I'm going to stretch this up. Since we already saw what's on that screen, we don't need to continue to see that. There we go. And if this is 7/2, 7/2 squared, well, we square the numerator, square the denominator. Wait, 7 squared is 49. 2 squared is 4. We want 49/4. Dang it, that's what we have. So these keep looking really complicated, but it's actually not. So it just comes out to be x plus 7/2 over 2 equals 0. Let me search again for one that's worse. That looked like it wasn't going to work out nicely, but it did. Going to pick up right where we left off, except with one that hopefully works out worse. It looks like from our work that nobody got this one right. Now, that might just mean that only one person attempted it. Well, 4x squared plus 20x plus 25. Divide everything by 4, which we've already established is the method to start, at least when the form of our answer is restricted. 25/4. Now that's going to work out too, right? Because half of, no wait, this won't work out. Ah, yes it will, because we'll have 5/2. Man, we got to review these as a class then. People keep making mistakes on this. I mean, this is good, and I'm going to keep this in the video. But when we think through our process, as we're doing x plus half of b squared, our constant term is going to be this value squared. Square the numerator, square the denominator. This does work out. Now, if I go look at, this is how I'm picking my questions. As I look at our homework and I look at, like, correct answers versus not, and I'm not going to drag the screen to be able to see who got things wrong. We do have one in this form. We have one like this where we have a leading coefficient of 2. So we can practice one of these where we do end up with a different leading coefficient out here. This one looks like we would definitely need to modify. So if I squiggly line and say x squared plus x minus 72, equals 0, of course. That's not the screen I wanted. I want this screen. So we skip a little bit and think through, okay, x plus, well, half of b. My b is 1. So half squared equals 0. This would come out to be, and I broke my own rule of ignore the constant for a moment. So if I ignore that constant for a moment, x plus 1/2 squared would be x squared plus 1x plus 1/4. right? This constant squared. So I need to turn my constant into a positive 1/4. What is it now? Negative 72. So I need to add to both sides, where's my red? 72 1/4. When we do that, we now get x squared plus x plus positive 1/4, which is x plus 1/2 squared. But that's now equal to 72 1/4. So this is not equal to 0. That's why it's always dangerous if we write the 0 ahead of time, which I should have known better. This is equal to 72 1/4. Now, if we remember our HK form, right, we wrote this down last week. The form of our vertex form of parabolas is x minus h squared plus k. Excuse me, equals 0. So we gotta make this equal 0. Well, we can do that, right? If we subtract 72 1/4 from both sides, and this is not necessarily the route that you'll see if you look up how other people do it. Another thing we could have done, so I'm trying to make sure that if you go watch other people, it makes sense what they're doing. If at the beginning we added 72 to both sides to get rid of it, we would have had x squared plus x equals a positive 72. Then when we added on both sides, we would have just added 1/4. So we would have added 1/4, and my 72 would have became 72 1/4. So we get to the exact same place, regardless which route we took. But then, to bring this back to quadratic and make it equal to 0, we have to rewrite it as x plus 1/2 squared minus 72 1/4 equal to 0. And now it's the opposite of h. So my vertex, opposite of our h, and what our k is. So we're going to keep that negative on it. So our vertex is negative 1/2, negative 72 1/4. Now remember, this shouldn't be that surprising, because when we look at the parabola to start, it's been shifted down by 72. Like, that's just straight up a vertical shift. So does that process make sense of how to modify both sides to get to the actual perfect square form? Because this expanded is this, so that's why we came back and added on both sides to get the result that we wanted on both sides. We can do another if you want. Do you want to do any of the ones with the different leading coefficient? So ones like this.